So in this problem, we need to determine the equation of an ellipse whose focus is at the point -1, 1 with directrix given by x minus y plus 3 equals to 0 and the eccentricity of the ellipse, that's 1/2. Let's begin. Let's try to understand the problem graphically first. So here we have the vertical straight line that's going to be referred to as the directrix. So its equation is x minus y plus 3 equals to 0. Then we have a line that is perpendicular to the directrix line, and this line will be the axis of the ellipse. On the axis we have a point f, and f is going to denote the focus of the ellipse. Its coordinates are -1, 1. To find out the equation of the ellipse, what we'll do, we'll consider a point P on the plane containing the directrix and the axis with coordinates x, y. So P is going to be referred to as the locus of the ellipse, and the position of P is very important. The position of P is chosen in such a way such that if we take the ratio of the length PF to that of PM, PM is going to be the perpendicular distance of point P from the directrix line, then this ratio is always a constant with a value equals to 1/2, which is the eccentricity of the ellipse. So this is by definition. So we'll start from here. So we'll take 2 times PF equals to PM. Okay, now PF can be easily obtained by using the distance formula since we have the coordinates of its endpoints. So we have 2 times the square root of, we'll have to take the difference of the x coordinate. So we have x minus -1, that gives us x plus 1. Square this and then add it to the difference of the y coordinate. So that's y minus 1. So y minus 1 whole square. So this will be equals to PM. Now PM is the perpendicular distance that we need to obtain. Okay, fine. So let's find out the perpendicular distance. So here we have a point P with the coordinates x1, y1. We have a straight line with the equation ax plus by plus c equals to 0. From point P we are dropping a perpendicular on the straight line, meeting it at M. Then this perpendicular distance PM is given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So here we have the absolute value. So inside the absolute value, we're going to take a ratio. We'll start with the coefficient of x of the directrix. So coefficient of x of the directrix, that's 1. 1 will get multiplied to the x coordinate of point P. So that's x. This will get added to coefficient of y, so that's -1. -1 will get multiplied to the y coordinate of point P. And then this will be added to the constant term plus 3. So we're going to divide it by the square root of, we have to take the sum of the squares of the coefficient of x and y. That means we take 1 squared and add it to -1 squared. So we get we're going to square both sides. Squaring both sides gives us 4. Squaring 2 gives us 4. And then we have multiplied to it x plus 1 whole squared plus y minus 1 whole squared. This will be equals to, so here we have x minus y plus 3, that we get x minus y plus 3 whole squared divided by square root of 2, but squaring it gives us 2. Now when we simplify this and combine all the like terms, we are going to get an equation that will be given by 7x squared plus 7y squared plus 2 times xy plus 10x minus 10y plus 7. And this is going to be the equation of the required, ellipse whose equation of directrix, coordinates of the focus and the eccentricity are known.